Alright, we're going to learn about the difference of squares. Whoa, not those squares. Yeah, more like those squares. Let's first write down what perfect squares are. They are like, what is 1 squared? That's 1. So 1's a perfect square. What is 2 squared? 4. What is 3 squared? 9. What is 4 squared? 16. Let's see if you can name the next few, and I'll post them in just a second. That's right, 25, 36, 49, 64, 81, 100, 121, 144, and we'll stop at 169 for 13 squared. Alright, so given a squared minus b squared, you're going to write the factors as a minus b times a plus b. And notice that those factors don't have any squared on them, so that means all you're doing is taking the square root. So you're basically taking the square root of the first and second terms. Alright, go ahead and pause the video if you need to. And I'm going to jump to example 1. Alright, so did you identify perfect squares with 36x squared minus 25? Sure, they're both perfect squares. So if we took the square root of the first term and the square root of the second term, the square root of the first term is 6x. And yes, x squared is a perfect square because x times x gives us x squared. And then square root of 25 is 5. And then all we do is write them twice. And one of them gets a plus sign, the other one gets a minus sign. And don't forget, you use the box method to check, or the FOIL method, whichever you prefer. I'm going to show the box method. This just proves that my factoring was correct. So I write 6x plus 5, 6x minus 5, and I'm just going to do 6x times 6x, that's 36x squared. 6x times 5 is 30x. 6x times negative 5 is negative 30x. And negative 5 times 5 is negative 25. Remember, your like terms are almost always going to be those diagonals. So just combine them, and what do you notice about 30x minus 30x? That's right, it cancels out. So we're left with 36x squared minus 30x. I'm sorry, minus 25. Is that what we started with? Yes. So we definitely got it right. You can always use the box method to check to make sure you did it right. Alright, let's try another example. Alright, are they both perfect squares, both terms? Yes. The square root of 49 is 7. The square root of 4 is 2. And our y's and our x's are both squared, so that means it's going to be 7y. And the square root of 4 is 2, so that's 2x. We just write it twice, so 7y and 2x. And remember, one of them gets a plus, and the other one gets a minus. Do you know why that is? Well, how do you think we get this minus sign? What are your multiplication rules? If you multiply a positive times a negative. So that's why they had to be one positive and one negative. Alright, and now just to check it, let's use the box method. And I do 7y times 7y, I get 49y squared. Negative 2x times 7y is negative 14xy. 7y times 2x is 14xy. And negative 2x times 2x is negative 4x squared. And your diagonals are your like terms here. They both have xy's. And they cancel out because negative 14 plus 14 is nothing. So we're just left with the 49y squared minus the 4x squared. Is that what we started with? Yes, so we got it right. Alright, now we're going to try on our next example, we're going to try a solution. Alright, so same deal here. We have two perfect squares, so we can do difference of squares. So square root and square root. And square root of 25 is 5. And the square root of x is x. So that's 5x. Square root of 1 is 1. And I just write it twice. One of them gets a plus. The other one gets a minus. And notice this is set equal to 0. So my directions here would be to solve. So whenever we solve, we always factor first, and then we set them both equal to 0. So I'm going to write 5x plus 1 equal to 0. I'm going to write 5x minus 1 equal to 0. And it's a two-step equation, so minus 1 minus 1. We get 5x equals negative 1. Divide by 5, divide by 5. And x equals negative 1/5. On the other side, plus 1 plus 1, 5x equals 1. Divide by 5, and x equals 1/5. Now in the future you'll probably see that you only need to do this once, because they're always going to be the same number, just different signs. So this one's a negative 1/5, that one's a positive 1/5. So I'm going to write my final answer in set brackets. So negative 1/5, comma 1/5. And that is your solution. And remember, you can always check these factors with the box method. Alright, let's try one more. Alright, remember on example 4 it says solve 52x squared minus 6 equals 3x squared minus 2. Remember, we always want to set it equal to 0, and in other words, put it in standard form. So this is not in standard form at all. So I'm going to shift everything to one side. So I'm going to do minus 3x squared and plus 2. I'm going to do the same thing to the other side. So minus 3x squared. Notice I'm lining up my like terms. And here I put the plus 2 under the minus 6, my two constants. These cancel there on the right. So now I have nothing on the right hand side. And on the left, 52 minus 3 is 49x squared. And then negative 6 plus 2 is negative 4. And now I have two perfect squares. 49, square root of 49 is 7, square root of 4 is 2. So I'm just going to take the square root of each of them. That's 7x and a 2. 7x and a 2. I always write it twice. And remember, one of them gets a plus sign, the other one gets a minus sign. Alright, we can check that with the box method. We should know how to do that by now. So I'm just going to set these both equal to 0. And remember, you only need to really show the work on one of these, because you know that once you get one answer, the other one's going to be the same thing, only opposite signs. So we get 7x equals negative 2, divide by 7, and x equals negative 2/7. Do the same thing on the other side, you'll get x equals 2/7. And we always write our final answer in set brackets. So negative 2/7, comma 2/7. Alright, try the next one on your own, and we'll check it. Alright, here you go. Solve 32x squared minus 11 equals 4x squared minus 2. Go ahead and pause the video and try this one on your own. And here for the solution. There's our first step. Solve for 0. And hopefully you found a mistake here. It's not a perfect square. So why don't we do this? Why don't we change that problem around and make that a negative 4x squared? And that's where we should be now. Now go ahead and pause the video. Sorry about that. Hopefully you figured out that it could not be solved that way, because 28 is not a perfect square. Alright, pause the video, try to finish that out. And here we go. And that's our next step. And those are our two factors, 6x minus 3 and 6x plus 3. And finally, our two solutions are negative 1/2 and positive 1/2. Did you get that right? I hope so. And now you know how to solve using difference of squares.